December 7th, 1942. Exactly 1 year to the day after Pearl Harbor. The morning shift at Newport News Shipbuilding trudged through the Virginia cold toward Shipway 11, their breath visible in the pre-dawn darkness. They carried lunch pails and thermoses, worn gloves and welding masks. Most were still learning trades they'd never heard of 6 months earlier. Some were women who'd never held a torch before 1941. Others were men too old for the draft, pulled from retirement to teach skills the younger generation needed to master in weeks rather than years. In Shipway 11, surrounded by wooden scaffolding and the smell of cutting metal, sat a steel keel barely 20 feet long. 2 massive plates, each weighing 15 tons, had been positioned on keel blocks the previous evening. This morning, the welders would join them. It was the first steel of a new aircraft carrier, hull number CV-13, to be named Franklin. The schedule called for her to be commissioned in 36 months, 3 full years from keel to combat readiness. That's what peacetime shipbuilding demanded. Careful work, methodical progress, no mistakes. But this wasn't peacetime. 1 year earlier, Japanese bombs had shattered the Pacific Fleet at Pearl Harbor. 6 months ago, American carriers had turned the tide at Midway, but at brutal cost. Yorktown lay at the bottom of the Pacific. Lexington was gone. Wasp would be sunk in September. Hornet would follow in October. America was hemorrhaging carriers faster than peacetime construction could replace them. The Navy needed Franklin operational not in 3 years, but in 14 months. Not by April 1945, but by January 31st, 1944. 14 months to build a vessel 872 feet long, displacing 27,000 tons, containing millions of pounds of steel, thousands of miles of cable, complex propulsion machinery, weapons systems, radar equipment, and accommodations for over 3,000 men. 14 months to create a floating city that could launch and recover 80 aircraft while steaming at 33 knots through hostile waters 5,000 miles from home. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Every naval architect who reviewed the schedule said the same thing. Impossible. You can't compress carrier construction that dramatically without catastrophic quality failures. The engineering is too complex. The systems too intricate. There aren't enough skilled workers. The supply chains can't keep pace. Something will break. The ship will break. Men will die. But on that cold December morning in 1942, as the first welders struck their arcs and molten metal began joining those 15-ton keel plates, Newport News Shipbuilding wasn't planning to prove the experts wrong. They'd already proven them wrong. 4 shipways away, in Shipway 7, another carrier was nearing completion. USS Essex, hull number CV-9. She'd been laid down in April 1941, with a scheduled completion date of April 1944, 36 months, just like Franklin. But Essex wasn't going to take 36 months. She was going to commission in less than 3 weeks, on December 31st, 1942. 20 months from keel to commissioning, the yard had already shaved 16 months off the predicted schedule, and Essex wasn't alone. In Shipway 8, USS Yorktown, the second of the class, was fitting out for her January launch. In Shipway 10, USS Intrepid was taking shape, her hull plates rising toward the winter sky. Across the yard, 3 more Essex-Class keels would be laid down before 1943 ended. Newport News had 7 of these massive carriers on order. 7. The largest single-yard carrier construction program in naval history. And the yard had promised the Navy something that sounded like madness. 1 carrier every 3 months, 4 per year. A production rate that would see completed fleet carriers rolling out of Newport News like automobiles from Detroit assembly lines. The man who'd made that promise sat in the shipyard's main office overlooking the James River. Homer Lenoir Ferguson was 70 years old in December 1942. He'd been president of Newport News Shipbuilding since July 1915, when his predecessor drowned aboard RMS Lusitania. Ferguson had guided the yard through World War I, through the lean treaty years of the 1920s, through Depression-era desperation, when the yard built railroad cars to keep workers employed. He'd designed battleships and cruisers, pioneered welding techniques, established America's premier shipyard apprentice program. He was the dean of American naval architecture, a quiet engineer who preferred slide rules to public appearances. But Ferguson understood something in December 1942 that transcended any particular design or innovation. He understood time, not clock time or calendar time, but industrial time. The rhythm of steel through rollers, the sequence of welds that built a hull, the critical path that determined whether a ship commissioned in 14 months or 40. Ferguson had spent 2 years studying that rhythm, breaking it down, finding where time was lost not to complexity, but to convention, to the assumption that certain things had to happen in certain orders because they'd always happened that way. The conventional wisdom about carrier construction went like this. You lay the keel. You build the hull from the keel upward, one plate at a time, carefully fitting each piece. When the hull is substantially complete, you launch the ship. In the water, you install the island superstructure, the flight deck, the catapults, the AR resting gear. You fit out the interior spaces, run the electrical, cables, install the plumbing, mount the guns. You conduct sea trials, discover problems, fix them. You commission the ship and begin training the crew. Linear, sequential, methodical. Ferguson had thrown out every assumption in that process. Not the engineering principles, those were immutable. Not the quality standards, those were non-negotiable. But the sequence, the timing, the organization of labor and materials. Everything about how a carrier moved from concept to completion. The revolution began with steel. In traditional shipbuilding, steel arrived at the yard as plates and shapes. Workers measured, cut, formed, and assembled these pieces on the building ways. Every carrier was unique because every piece was cut and fitted individually. Ferguson looked at that process and saw automotive manufacturing. Henry Ford didn't build cars by hand-fitting unique pieces. He used standardized components, pre-manufactured to precise specifications, assembled according to carefully orchestrated sequences. Ferguson convinced the Navy to allow standardization across the entire Essex-Class. Every ship would use identical structural members wherever possible. Frames, bulkheads, deck plates, all would be cut to the same dimensions from the same drawings. More importantly, these pieces would be pre-cut at steel rolling mills before arriving at the yard. Newport News would receive not raw steel plates, but formed sections ready for immediate assembly. This decision cascaded through the construction process. Workers didn't need to measure and cut. They needed to assemble pre-cut pieces. That required different skills. Easier to teach, faster to master. A new hire with 3 weeks training could position and weld a pre-cut frame section. The same worker would need 3 months to measure, cut, and fit that frame from raw plate. By pre-cutting at the mills, Ferguson converted a skilled task into a semi-skilled task, expanding the available labor pool by an order of magnitude. But pre-cut steel was only the beginning. Ferguson implemented prefabrication on a scale never attempted in naval construction. Traditional shipbuilding assembled everything on the building ways. You built the ship where it sat. Ferguson created separate fabrication sheds throughout the yard. In Fabrication Shed 3, teams assembled bow sections. In Shed 7, stern sections took shape. Shed 12 produced island superstructures. Each section was a complete subassembly, fully welded, stress-relieved, inspected, before ever reaching the building ways. The building ways became final assembly lines. Instead of constructing a carrier plate by plate over 18 months, the ways received large prefabricated sections that came together over 6 to 8 months. Bow section, forward hull sections, midship section with boiler rooms and engine spaces, aft hull sections, stern. Each section arrived substantially complete. Workers on the ways connected sections rather than building from scratch. This modular approach transformed scheduling. In traditional construction, Every task waited for the previous task to complete. You couldn't install boilers until the engine room hull was built. You couldn't run electrical cables until bulkheads were welded in place. Everything was serial, one step after another. With prefabrication, tasks happened in parallel. While the bow section was being assembled in Shed 3, the engine room section was being built in Shed 9. While both were under construction, workers in Shed 15 were installing the boiler machinery that would be placed in the engine room section when it reached the ways. Ferguson hired industrial engineers from automobile companies to redesign the yard's workflow. These men knew nothing about ships, but they understood bottlenecks, throughput, and critical path analysis. They mapped every task required to build an Essex-Class carrier, identified dependencies, calculated durations. They created enormous flowcharts showing how thousands of tasks interwove. Then they found ways to break dependencies, to allow more work to proceed simultaneously. The result was a construction ballet of stunning complexity. On any given day in late 1942, Newport News had parts of 7 different carriers under construction in different locations. In the fabrication sheds, workers assembled sections for carriers that wouldn't have their keels laid for months. On the building ways, hulls rose as prefabricated sections arrived in carefully orchestrated sequences. At the fitting-out piers, recently launched carriers received final equipment installation. In the dry docks, completed carriers underwent final inspections and sea trials. The yard operated 24 hours a day, 7 days a week. 3 shifts, 8 hours each, with overlap periods where shifts shared knowledge and caught mistakes before they propagated. The day shift, 7 in the morning to 3 in the afternoon, did the bulk of the heavy work. Cranes moved prefabricated sections. Welding teams joined hull plates. Electricians ran cable. The evening shift, 3 in the afternoon to 11 at night, continued the work but also performed quality inspections, catching errors while they could still be fixed easily. The night shift, 11 at night to 7 in the morning, focused on specialized tasks that required quieter conditions. Precise instrument installation, delicate electrical work, tasks where the daytime hubbub would be distracting. Managing this complexity required a workforce that barely existed in 1941. Newport News employed 10,000 workers when war broke out. By April 1943, the yard employed 31,000. Where did they come from? Everywhere. Men from the coal fields of West Virginia, looking for steady work after the mines closed. Farmers from the Virginia Piedmont, driven by curiosity and patriotism. Women from Newport News itself. From Richmond, from Norfolk, from tobacco country and fishing villages. Teenagers who lied about their age. Grandfathers who came out of retirement. A man who'd built fishing boats in Florida. A woman who'd worked an assembly line at a textile mill in North Carolina. None of them knew how to build aircraft carriers. Most had never seen an aircraft carrier. They arrived at the yard's employment office, filled out paperwork, submitted to basic physical examinations, and reported for training if accepted. The training lasted anywhere from 2 weeks for basic labourers to 12 weeks for welders. The yard's apprentice school, established in 1919, expanded dramatically. New welding schools opened in leased buildings around Newport News. Instructors worked overtime teaching theory in the morning, watching students practice in the afternoon. The training focused obsessively on one thing, not understanding why things worked, but understanding exactly how to do one specific task, correctly, repeatedly, safely. A new welder didn't need to understand metallurgy or stress analysis. She needed to strike an arc at the correct angle, maintain the correct travel speed, produce a weld bead that met Navy specifications. Measure twice, weld once. Check the specification card. Follow the sequence. Ask for help if uncertain. This narrow specialization allowed rapid training, but it created a new problem. In traditional shipbuilding, experienced workers understood how their work fit into the whole. They caught systemic errors because they saw the broader context. Ferguson's specialized workers saw only their specific tasks. A welder joining hull plates didn't know whether those plates would later support a gun mount or a fuel tank or crew quarters. She just knew the sequence. Weld number 1 here, number 2 there, check for cracks, call the inspector. To catch systemic errors, Ferguson created an army of inspectors. Not just final inspectors checking completed work, but inline inspectors monitoring every step. Every weld received immediate inspection. Every prefabricated section underwent dimensional checks before leaving its fabrication shed. Every piece of equipment installed aboard ship came with paperwork tracking its origin, its specifications, its test results. Nothing proceeded to the next step without approval. The inspection regime slowed individual tasks, but accelerated overall progress. A defective weld caught immediately took 10 minutes to fix. The same weld, discovered during final sea trials, might require days to access, repair, and re-inspect. Better to catch problems at the source, even if it meant more inspectors, more paperwork, more interruptions. By December 1942, this system was humming. USS Essex was days from commissioning, on schedule, on budget, with no major defects. USS Yorktown would follow in April, USS Intrepid in August, USS Hornet in November, and now, in Shipway 11, USS Franklin's keel was laid, the first steel of what would be the fastest Essex-Class carrier ever built. But the system that made this possible rested on a foundation that Ferguson had spent 2 years building quietly, without fanfare, in careful collaboration with steel mills, equipment manufacturers, and the Navy's Bureau of Ships. It was a foundation that would determine not just whether Franklin commissioned in 14 months, but whether she'd survive the war when other carriers didn't. The steel that arrived at Newport News in late 1942 came from mills across America, but it wasn't ordinary shipbuilding steel. It was special treatment steel, designated STS in Navy specifications. A nickel-chromium alloy developed by Carnegie Steel around 1910 that combined the strength of structural steel with the protective qualities of armor plate. STS could stop shell fragments, resist crack propagation, and maintain structural integrity under battle damage that would shatter conventional steel. Ferguson had insisted on STS throughout the Essex-Class design, not just for critical areas like the hangar deck or machinery spaces, but everywhere structural strength mattered. Hull frames, bulkheads, deck beams. The decision added roughly 30% to material costs, but Ferguson's calculations showed that STS contributed to both strength and protection. A hull built with STS could be lighter than a conventional design while being more survivable. You weren't paying for armor, you were paying for a ship that wouldn't sink. The Navy had initially balked at the expense. In early 1940, when the first Essex-Class contracts were negotiated, the Bureau of Ships wanted conventional mild steel for most of the structure, reserving expensive STS for targeted protection. Ferguson presented his case with characteristic precision. An Essex-Class carrier, using STS throughout, would weigh less than a conventionally protected design. That weight saving meant more aircraft, more fuel, more ammunition. More importantly, the structural redundancy created by using armor-grade steel everywhere meant battle damage that would cripple a conventional carrier might be survivable. He didn't argue about strength or protection in abstract terms. He showed calculations. If you lose 3 adjacent bulkheads in a conventional design, you lose structural integrity across that entire section. If you lose 3 bulkheads made of STS, the remaining structure maintains adequate strength because every member is built to armor-grade specifications. It's not that the ship doesn't get damaged. It's that damage doesn't cascade catastrophically. The Bureau of Ships approved the STS specification in July 1940. By December 1942, when Franklin's keel was laid, American steel mills had retooled to produce STS in quantities that would have been unimaginable 2 years earlier. The mills delivered pre-cut sections to Newport News on schedules coordinated down to individual railcars. Section 23 for Franklin's bow arrived on December 15th. Section 24 arrived December 17th. Section 25 on December 19th. Like clockwork, like an assembly line receiving parts. But the steel was only one element of a supply chain that Ferguson had orchestrated with obsessive attention. A carrier contained thousands of components beyond structural steel: boilers from Babcock and Wilcox, turbines from Westinghouse, radar systems from dozens of manufacturers, gun mounts, catapults, elevators, generators, pumps, valves, miles of electrical cable, thousands of lights, switches, instruments. Everything had to arrive in the correct sequence, at the correct time, or the schedule collapsed. Ferguson hired logistics coordinators whose sole job was tracking components and scheduling deliveries. These men, working from offices in the yard's main administration building, maintained enormous wall charts showing every carrier under construction and every major component required. When would Franklin need her boilers? February 1943. The boilers needed to leave Babcock and Wilcox's factory in Ohio by January 15th to allow for rail shipping and installation preparation. That meant B&W needed to start fabrication in October 1942. The coordinators sent representatives to supplier factories to monitor progress. Not to supervise manufacturing, the suppliers knew their business, but to spot delays before they became crises. If B&W's boiler production hit a snag in November, the coordinator knew immediately. He notified Newport News, who adjusted Franklin's construction sequence to work around the delayed boilers. Maybe advance the electrical installation that was scheduled after boiler installation. Maybe accelerate the flight deck framing that didn't depend on boilers at all. Stay flexible. Keep the critical path moving. This flexibility required workers who could shift between tasks rapidly. In Shipway 11, where Franklin was rising from her keel, the construction superintendent maintained a whiteboard showing that day's priorities. Monday morning, December 14th, 1942, the board showed 43 active tasks. Welding teams 1 through 7 were joining hull plates in the forward section. Welding teams 8 through 12 were working on the after section. Electricians were pulling cable through completed sections of the double bottom. Pipe fitters were installing fuel lines. Riggers were positioning a prefabricated bulkhead for installation. By Monday afternoon, the board had changed. Welding Team 3 had discovered a dimensional error in a hull plate. Not a quality problem, but the plate was 3/8 of an inch too narrow. An inspector confirmed the problem. The plate came from the wrong batch at the rolling mill. It met specifications for a different section of the ship. The construction superintendent made a decision in under 5 minutes. Halt at work on that section. Redirect Welding Team 3 to the after section, where they could continue productive work. Call the supply coordinator. Rush order the correct plate from the mill. Expected delivery, Wednesday morning. Resume work on that section Wednesday afternoon. This kind of dynamic problem-solving happened dozens of times per day, on every carrier under construction. It required trust between management and workers. The workers on Welding Team 3 weren't disciplined for discovering an error. They were thanked. The inspector who confirmed the problem received a commendation. The system rewarded catching problems, not hiding them. Better to halt work for 2 days than install a defective plate that would cause problems for 2 decades. The workforce that made this possible came from backgrounds that had nothing to do with shipbuilding. Sarah Morrison, 23 years old in December 1942, had worked at a textile mill in Greensboro, North Carolina before the war. She'd operated a loom, producing cotton fabric for clothing manufacturers. When the mill laid off workers in April 1942, Morrison saw an advertisement for shipyard jobs at Newport News. Good pay, patriotic work, housing assistance available. She took a bus to Virginia, filled out an application, started welding school the next Monday. The welding school lasted 6 weeks. Morrison learned to strike an arc, control heat input, produce consistent bead width and penetration. She practiced on steel plates until her instructor certified her welds met Navy specifications. Then she reported to Fabrication Shed 7, which produced stern sections for Essex-Class carriers. Her first assignment was welding deck plates, flat, horizontal welds, the easiest type. She practiced for a week under supervision. Then she was on her own, following specification cards, welding plates in the prescribed sequence, calling for inspection after every fifth weld. Morrison discovered she had a talent for welding. She maintained steady hand speed, kept consistent arc length, produced uniform beads. Within 3 months, she'd advanced to vertical welds, which were harder. Within 6 months, she was certified for overhead welding, the most difficult position, welding from beneath while molten metal tried to drip on her. By December 1942, Morrison was one of the yard's lead welders, training new hires, troubleshooting problems, mentoring women who arrived scared and uncertain. She was one of thousands of women who flooded into shipyard work after 1941. By April 1943, when Newport News reached peak employment of 31,000 workers, approximately 6,000 were women. They worked as welders, electricians, crane operators, painters, inspectors. They weren't segregated into women's work. They performed the same jobs as men, held to the same standards, paid the same wages. This wasn't enlightened social policy. It was desperate necessity. The men who traditionally filled skilled shipyard jobs were being drafted into military service. The yard needed workers. Women were available, capable, and eager for good-paying jobs. The yard trained them and put them to work. Some male workers resented the change. Most recognized reality. The carriers had to be built. If women could weld steel that met Navy specifications, their gender was irrelevant. But the work was brutal. 8-hour shifts in winter, cold or summer heat. Welding inside steel compartments where temperatures reached 110 degrees, grinding and fitting tasks that left hands blistered. Crane operators who sat in exposed cabs 50 feet above the ground in all weather. Pipe fitters who crawled through spaces barely large enough for a human body. Electricians who worked with live power, always one mistake from electrocution. The injury rate was significant but not catastrophic. The yard employed full-time safety inspectors who enforced rules about protective equipment, ventilation, fire precautions. Workers received basic safety training before starting work. They learned to watch for falling objects, avoid pinch points between moving equipment, maintain 3 points of contact when climbing. Common-sense rules that saved lives when followed. Deaths happened anyway. In March 1943, a crane operator moving a 10-ton section of hull plating lost control when a lifting cable parted. The section swung into scaffolding where 3 workers were fitting pipes. 2 workers dove clear. The third, a 51-year-old pipe fitter named Robert Hayes, was crushed. The yard shut down for 2 hours. An investigation determined the cable failure resulted from hidden corrosion. All lifting cables were inspected and replaced if any doubt existed about their condition. Hayes's death affected the workforce deeply. He'd been popular, a veteran shipyard worker who'd come out of retirement to help the war effort. His funeral drew over 200 co-workers. The yard's president, Homer Ferguson, attended personally and spoke with Hayes's widow. He committed to a $10,000 death benefit, a huge sum in 1943, to help support her and their 2 children. But the work continued. The carriers had to be built. Hayes's pipe-fitting crew, devastated, took 2 days off, then returned to work. His supervisor spoke plainly. Robert would want us to finish these ships. Men are dying in the Pacific because we don't have enough carriers. Every day we delay, more men die. The best way to honor Robert is to finish Franklin, to get her into combat where she can make a difference. By January 1943, Franklin's hull had begun to take recognizable form. The double bottom, the warren of small compartments forming the ship's lowest level, was substantially complete. The main deck beams were in place. The forward hull sections were rising toward their final height. In fabrication shed 9. Workers were assembling the massive engine room section, a prefabricated unit 30 feet wide, 40 feet long, and 3 decks tall that contained the foundations for the main turbines. This section would be lifted by the yard's largest crane and lowered into Franklin's hull in early February. It weighed over 100 tons. The lift had to be precise within half an inch because the section had to mate with already installed structure at dozens of connection points. A team of riggers spent a week preparing. They calculated load distributions, positioned the crane, installed guide cables. On February 8, 1943, on a cold morning with light wind, they made the lift. The crane's operator, a 45-year-old man named Thomas Whitaker, had 30 years of experience. He'd lifted everything from small boats to battleship turrets, but this lift made him nervous. 100 tons, swinging 70 feet above the ground, settling into a space with inches of clearance on all sides. He proceeded in slow motion. Lift 6 inches, hold, check for sway, lift another 6 inches. It took 45 minutes to raise the section to lifting height, another 30 minutes to position it over Franklin's hull, then the delicate process of lowering it into place. Workers on scaffolds inside the hull guided the section with ropes. Forward 6 inches, one called through a bullhorn. Whitaker adjusted. Port 2 inches. Adjust. Down 1 foot. The section descended slowly. The guides watched the connection points. Steel flanges on the section had to align perfectly with mating flanges on the hull structure. Hold, one guide called. The section hung motionless, while workers checked alignment. We're good, down 6 inches. The section settled. The flanges touched. Perfect, set it down. Whitaker lowered the section onto its foundations. Welders immediately began tacking it in place while the crane hooks were disconnected. The entire lift, from first movement to final positioning, took 3 hours and 40 minutes. 0 errors, 0 damage. Whitaker climbed down from his crane cab at the end, shaking from adrenaline and cold. His supervisor handed him coffee. Textbook, the supervisor said. Whitaker just nodded. He'd do 3 more lifts like that before Franklin was complete. Each one scared him. You couldn't get comfortable with that much weight hanging overhead. By March 1943, Franklin's construction was ahead of schedule. The hull was 80% complete. The machinery spaces were framed. The island superstructure, being fabricated separately, was ready for installation. Ferguson visited Shipway 11 regularly, walking through the hull, asking questions, checking progress against his mental timeline. He said little, but the construction superintendent knew Ferguson's silences. If Ferguson was quiet, things were going well. If Ferguson started asking detailed questions, he'd spotted something that worried him. On March 22nd, Ferguson spent 2 hours in Franklin's forward hull examining bulkhead installations. He measured clearances with a carpenter's square, checked weld beads with a magnifying glass, traced cable runs with his finger. Finally, he found what had bothered him. A ventilation duct ran through a watertight compartment in a way that created a potential weakness. Not a specification violation, the installation met the drawings, but the drawings were wrong. Ferguson called for the ship's architect, a young naval constructor named James Harrison. Harrison arrived 20 minutes later, slightly nervous. Ferguson didn't typically call for architects unless he'd found a problem. Ferguson showed him the duct routing. This duct penetrates the compartment boundary here, Ferguson said, pointing. If we take damage that breaches this compartment, water will flood through the duct into the adjacent compartment. The compartmentation doesn't work. Harrison looked at the drawings, then at the installation, then at Ferguson. Sir, the design matches the approved plans. We followed the Essex-Class standard. The standard is wrong, Ferguson said flatly. The Essex-Class carriers built so far haven't been tested by this kind of damage. But they will be. This duct needs to be rerouted through a non-watertight space, or we need to install flood dampers that will close automatically if the compartment breaches. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Harrison made a quick decision. Installing automatic flood dampers would take days, but wouldn't require rerouting the entire duct. He called for the ship's ventilation engineer. Within an hour, they'd designed dampers for that duct and for 17 similar ducts throughout Franklin. The dampers added weight and cost. They added 3 days to the schedule, but Ferguson's instinct proved prescient. When Franklin took catastrophic damage in March 1945, those dampers, closing automatically when compartments flooded, would help save the ship. This attention to survivability, to building in redundancy and protection, even when it slowed construction, characterized Ferguson's entire approach. He wanted carriers built fast, but he wanted them built right. Speed without quality was worse than useless. It was murderous. The men who'd serve aboard Franklin deserved a ship that would protect them, that would survive damage, that would bring them home. By May 1943, Franklin was ready for launch. The hull was complete. The machinery was installed but not yet tested. The island superstructure would be added after launch, along with the flight deck, catapults, and most of the weapons. Traditional shipbuilding would have waited to launch until the ship was much further along, but Ferguson's system launched ships as soon as the hull was watertight and stable. This freed up the building ways for the next ship while fitting out work continued at the piers. On May 15, 1943, Franklin slid down the ways into the James River. Thousands of workers gathered to watch. A Navy band played. Local dignitaries made speeches. Lieutenant Commander Mildred McAfee, director of the Waves, christened the ship by breaking a champagne bottle against her bow. Franklin entered the water for the first time, displacing water, floating free, held by tugs that nudged her toward the fitting-out pier. At the fitting-out pier, a different kind of construction began. The work shifted from structural assembly to systems integration. Workers installed the flight deck, the massive wooden surface that would allow aircraft operations. They erected the island superstructure, a 7-story steel building containing the bridge, flight control, radar platforms, and signal bridges. They mounted guns, 5-inch turrets, 40mm quad mounts, 20mm cannons. They installed radar antennas, radio systems, navigation equipment, and they tested everything. The boilers were lit off for the first time in June, gradually bringing steam pressure to operating levels. The turbines were turned over, slowly at first, then at increasing speeds. The electrical system was energized section by section. The fire suppression system was tested by actually flooding compartments with water and CO2, checking that valves operated correctly, that pumps delivered pressure, that the system would work when needed. Problems emerged. A steam line vibrated at certain turbine speeds, threatening to fracture from metal fatigue. Engineers added dampening supports. One of the boilers developed a leak in a feedwater line. Workers replaced the entire line rather than patching it. Better safe than sorry. The cost was 2 days and some pipe. The alternative was a catastrophic failure at sea. By August 1943, Franklin was nearing completion. Workers were installing interior fittings, painting compartments, mounting equipment that had been delayed by supplier issues. The flight deck was complete, a vast wooden expanse 862 feet long. The catapults, massive steam-powered devices that would hurl 20,000-pound aircraft to flying speed in under 300 feet, were being tested. The arresting gear, the cables that would stop landing aircraft, had been installed and calibrated. In October, Franklin began sea trials. The ship left the pier under her own power for the first time, steaming down the James River toward the Chesapeake Bay. The crew, a skeleton complement of sailors and shipyard technicians, put the ship through increasingly aggressive tests, engine trials at various speeds, steering tests, turning the ship at different speeds, checking responsiveness, communications tests, radar tests, gun firing tests, actually shooting the weapons to verify they worked as designed. The sea trials revealed minor issues: a vibration in the starboard shaft at high speed, a radar that intermittently lost contact, a gun mount that jammed when trained to extreme angles. None were showstoppers. All were fixable. The ship returned to the pier after each trial period. Workers made corrections. The ship went back out. Test again. Verify the fixes worked. On December 31st, 1943, USS Franklin was commissioned into the United States Navy. The ceremony took place at the Norfolk Navy Yard, across the harbour from Newport News. Captain James Shoemaker assumed command. The crew, now at full strength with over 3,000 officers and men, stood at attention on the flight deck. A Navy band played the national anthem. The commissioning pennant was raised. Franklin was officially a warship of the United States. The time from keel laying to commissioning, 12 months and 24 days. Not quite the 14 months that would make Franklin the record holder. That distinction went to her sisters, built even faster later in the war. But close enough. Close enough to prove that Ferguson's system worked. Close enough to show that aircraft carriers could be built at speeds that pre-war naval architects had declared impossible. But the proof wasn't just in one ship. By the end of 1943, Newport News had delivered 3 Essex-Class carriers. Essex herself in December 1942, Yorktown in April 1943, Intrepid in August, Franklin in December. 4 carriers in 12 months, exactly the production rate Ferguson had promised. 1 every 3 months, and there were more in the pipeline. Hornet would commission in November 1944, Ticonderoga in May 1944, Randolph in October 1944. The achievement wasn't in building one ship fast. It was in building an entire fleet fast, in creating a production system that delivered complex warships on predictable schedules with consistent quality, using a largely inexperienced workforce. That was the miracle. That was what won the war. But the system came with hidden costs that wouldn't become apparent until later. The relentless pace wore on everyone. Workers exhausted from 8-hour shifts, 6 days a week, month after month. Supervisors stressed by constant pressure to meet deadlines. Inspectors afraid of missing a defect that could cost lives. The yard operated at a tempo that couldn't be sustained indefinitely. Something had to give. In January 1944, as Franklin departed for her shakedown cruise and combat deployment, Newport News Shipbuilding faced a crisis that threatened to collapse the entire production system. The crisis wasn't steel shortages or equipment delays or design problems. It was people. The workforce that had grown to 31,000 in April 1943 had begun to shrink. Workers quit. Some left for higher-paying jobs at factories producing tanks or aircraft. Some left because they couldn't handle the pace anymore. Some left because family situations changed. Some were drafted despite their shipyard jobs supposedly qualifying for deferments. By January 1944, the workforce had dropped to 28,000. By March, it hit 26,000. Ferguson recognized the danger immediately. The production schedule for 1944 called for delivering 4 more Essex-Class carriers, plus starting construction on 2 new hulls. That required maintaining the workforce at close to 30,000. Dropping to 26,000 meant delays. Delays meant fewer carriers in the Pacific. Fewer carriers meant more American casualties. The problem wasn't recruiting. The yard could recruit new workers easily. The problem was retention. Training a new welder took 6 weeks. Getting that welder to full productivity took another 3 months. If workers quit after 6 months, the yard was constantly training replacements instead of building experience. And experienced workers were dramatically more productive than new hires. A welding team with 2 years' experience could produce 50% more weld footage per shift than a team of newly trained workers doing identical work. Ferguson appointed a committee to study the retention problem. The committee interviewed workers who'd quit, workers who'd stayed, supervisors, union representatives. They compiled a report that Ferguson read with growing concern. The primary reason workers quit wasn't pay. It wasn't conditions, though conditions were harsh. It was meaning. Workers who quit said variations of the same thing. I don't see the point anymore. I weld these plates, but I don't know what happens to them. I don't know if my work matters. I'm just a number doing repetitive tasks. It could be anybody. The system Ferguson had created, the specialization and modularity that enabled rapid construction, had stripped workers of the context that gave work meaning. They were cogs in a machine. Efficient cogs, productive cogs, but cogs nonetheless. Workers who stayed gave different reasons. I know my work matters because I see the ships. I watch Franklin taking shape. I see her commission and sail away. I read in the newspaper about carriers fighting in the Pacific. Some of those carriers, I helped build them. That means something. The difference wasn't in the work itself. It was in the connection between work and purpose. Ferguson made an unusual decision. Instead of trying to improve pay or conditions, he focused on meaning. He ordered the yard to begin giving tours of ships under construction to workers who weren't directly assigned to those ships. A welder working in Fabrication Shed 3, making bow sections, would get a tour of a carrier at the fitting-out pier. She'd see her bow section installed in the complete ship. She'd understand how her work fit into the whole. The yard established a small museum in the main administration building showing the history of ships built at Newport News. Photographs of battleships from World War I, models of cruisers from the 1920s, display cases with components from famous ships, and prominently, a growing wall of photographs showing Essex-Class carriers in combat. USS Essex striking Marcus Island in August 1943. USS Yorktown launching strikes during the Gilbert Islands campaign. USS Intrepid at the Battle of Leyte Gulf. USS Franklin recently arrived in the Pacific, conducting operations off the Mariana Islands. Workers could visit the museum during their lunch breaks. Many did. They stood in front of the photographs, studying the ships they'd helped build, reading the captions describing combat operations. It reconnected them to the purpose of their work. These weren't just steel plates and weld beads. They were instruments of war that were defeating America's enemies and protecting American servicemen. The yard also began, publishing a weekly newsletter, The Shipbuilder, distributed free to all employees. The newsletter contained personal stories from sailors serving aboard Newport News-built ships. A letter from a pilot on USS Essex, describing how the carrier's catapults allowed him to launch on missions despite rough seas. A testimonial from Franklin's damage control officer praising the ship's compartmentation and fire suppression systems. Stories that connected workers to the men their ships protected. These changes cost almost nothing. A few hours to conduct tours, a small room for the museum, a minimal printing budget for the newsletter. But they worked. Turnover began to decline in March 1944. By May, the workforce had stabilized at 27,000. By July, it was growing again, reaching 29,000. Workers stayed because they felt their work mattered. They could see the direct line between their daily tasks and American victory in the Pacific. But 1944 brought another challenge. The Navy changed the Essex-Class design midstream. Based on combat experience from earlier ships, the Bureau of Ships mandated modifications to all carriers under construction. The changes addressed survivability issues identified in actual combat, better ventilation systems that wouldn't spread fires, improved fuel storage with better containment, modified gun positions for better fields of fire, stronger flight deck supports to handle heavier aircraft. For carriers far from completion, the changes were relatively easy to implement. Just use the new drawings instead of the old ones. But for carriers already well along in construction, the changes were painful. USS Ticonderoga, being built in Shipway 7, was 50% complete when the new specifications arrived. Implementing the changes required tearing out completed work and rebuilding sections to the new standard. The construction superintendent for Ticonderoga, a veteran shipbuilder named Frank Morrison, Sarah Morrison's father-in-law who'd helped recruit her to the yard, faced an impossible choice. He could ignore the changes and finish Ticonderoga to the original specification. That would save 6 weeks on the schedule. Or he could implement the changes, accepting the delay but delivering a more survivable ship. Morrison took the problem to Ferguson. Ferguson didn't hesitate. Implement the changes. Every one. If the Navy says these modifications improve survivability based on combat experience, then we implement them. We're not building ships to meet schedules. We're building ships to keep sailors alive. Ticonderoga's schedule slipped by 8 weeks. The yard absorbed the cost, over $300,000 in rework, but when Ticonderoga commissioned in May 1944, she incorporated every lesson learned from earlier Essex-Class carriers in combat. The modifications would save lives. Ferguson considered that $300,000, the best investment the yard ever made. By mid-1944, the production system had reached maturity. The workforce was experienced. The supply chain was optimized. The construction techniques were refined through repetition. Newport News was delivering Essex-Class carriers with the regularity of precision clockwork. Hornet commissioned in November 1943. Ticonderoga in May 1944. Randolph in October 1944. The yard was on track to deliver 7 Essex-Class carriers by war's end, an achievement unmatched by any other shipyard in history. But success bred complacency in unexpected ways. The workers who'd joined in 1941 and 42, the pioneers who'd learned their trades under wartime pressure, were now veterans with 3 or 4 years of experience. They were confident, skilled, efficient. They were also tired, exhausted, operating on fumes. 3 years of 8-hour shifts, 6 days a week, under constant pressure. Even dedicated, motivated workers have limits. In September 1944, the yard reduced the standard work week from 48 hours to 40 hours. Workers now had 2 days off per week instead of 1. The change reduced productivity in the short term. Fewer hours meant less work completed per week. But the reduction improved quality and actually increased productivity per hour worked. Rested workers made fewer mistakes, worked more efficiently, had fewer accidents. Ferguson justified the change to the Navy by pointing out that worker fatigue had become a safety issue. Accident rates had climbed steadily through 1944. Nothing catastrophic, but the trend was clear. Tired workers made mistakes. Mistakes caused injuries and delays. Giving workers more rest time actually improved overall output by reducing errors and rework. The Navy accepted the argument reluctantly. Admiral Samuel Robinson, who oversaw carrier construction for the Bureau of Ships, visited Newport News in October 1944 to review the work schedule reduction. He walked through the yard with Ferguson, observing workers, asking questions. At the end of the visit, Robinson told Ferguson, "I'm not happy about the schedule reduction, but I trust your judgment. If you say this improves overall output, I believe you. Just keep the carriers coming." Ferguson made a promise. "Admiral, we'll deliver 2 more Essex-Class carriers before the war ends. The schedule won't slip. You have my word." Robinson shook his hand. Ferguson's word was gold. If he promised delivery, the ships would deliver. And they did. USS Shangri-La commissioned in September 1944. USS Lake Champlain in June 1945. The 7th and 8th Essex-Class carriers from Newport News. Neither ship saw combat before Japan surrendered in August 1945, but both were ready to fight, ready to contribute. Built in a Virginia shipyard by workers who'd learned their trades during wartime, who'd worked impossible schedules, who'd believed their work mattered. When Japan surrendered, the yard had 2 more Essex-Class carriers under construction. USS Tarawa and USS Valley Forge. Both were substantially complete. The Navy considered cancelling them. The war was over. Why finish ships that weren't needed? Ferguson argued for completion. The Navy had contracted for these ships. The steel was cut. The workers were employed. Cancellation would waste the investment already made and cost jobs at a time when converting to peacetime employment would be challenging enough. The Navy agreed to complete both ships, but at a reduced pace. No more 40-hour weeks, no more overtime, no more 3-shift operations. The yard scaled back to peacetime tempo. Workers who'd been deferred from military service enlisted now that the war was over. Others left for jobs closer to home, eager to return to normal life. The workforce shrank from 29,000 in August 1945 to 15,000 by December. Tarawa commissioned in December 1946, Valley Forge in November 1946. The 9th and 10th Essex-Class carriers from Newport News, built slowly, carefully, without the frantic urgency that had characterized wartime construction. They were better ships in some ways. Every lesson from the war incorporated, every system refined, every detail perfected. But they were also monuments to a period that had ended. The period when American industry operated at maximum capacity, when workers believed their labor directly contributed to national survival, when production schedules mattered more than profit margins. Ferguson retired in July 1946 at age 73. He'd spent 31 years as president of Newport News Shipbuilding. Under his leadership, the yard had built more aircraft carriers than any other facility in history. 10 Essex-Class fleet carriers, dozens of escort carriers, battleships, cruisers, destroyers, submarines. Over 50 billion pounds of steel transformed into floating cities that projected American power across the globe. His retirement was quiet. No ceremony. No speeches. A brief announcement in the company newsletter. Ferguson believed action spoke louder than words. The ships were his legacy, particularly the Essex-Class carriers. 24 ships of the class were completed across all yards. Newport News built 10 of them, nearly half, and built them to a standard that defined excellence. Of the 10 Essex-Class carriers that Newport News delivered, none were sunk. 0 losses to enemy action despite years of combat. USS Franklin came closest, taking catastrophic damage in March 1945 that killed 807 men. But Franklin didn't sink. She survived because the ship beneath her crew was built to survive. Built with STS bulkheads that contained explosions. Built with redundant systems that kept machinery running when primary systems failed. Built with the obsessive attention to detail that Ferguson had demanded. Sarah Morrison, the young woman from North Carolina who'd arrived at the yard in April 1942, knowing nothing about welding, worked at Newport News until 1953. She became a senior instructor at the yard's welding school, teaching the next generation of shipbuilders. She trained hundreds of welders over her career. Many of them went on to build nuclear carriers, nuclear submarines, ships even more complex than the Essex-Class. Morrison retired at age 54, her hands worn from decades of holding welding torches. She'd spent 11 years building the ships that won the war and trained the people who built the peace. At her retirement party, a supervisor presented her with a photograph of USS Franklin. Morrison had worked on Franklin's hull in late 1942, welding deck plates in Fabrication Shed 7. The supervisor told her, "You helped build this ship." This ship survived damage that would have sunk any other carrier. 807 men died that day. But 1,200 men survived. They survived because you and thousands like you built a ship that refused to die. That's your legacy. Morrison kept the photograph on her wall for the rest of her life. When visitors asked about it, she'd tell them about the war years, about working 8-hour shifts in all weather, about learning a trade she'd never heard of, about the satisfaction of watching ships she'd helped build slide into the James River and sail away to war, about knowing her work mattered, really mattered, in ways that most people's work never does. She died in 1987 at age 68. Her obituary in the Newport News Daily Press mentioned that she'd worked at the shipyard during the war. It didn't mention the specific ships she'd built or the lives her work had saved. The newspaper's readers wouldn't have known that the elderly woman who died quietly in a nursing home had been part of the greatest industrial mobilization in human history. That her welding torch had joined steel plates that protected American sailors thousands of miles from Virginia. That her skill and dedication had helped build ships faster than experts said was possible. But the ships remember. USS Essex served until 1969, USS Yorktown until 1970, USS Intrepid until 1974, USS Hornet until 1970, Decades of service, Korea, Vietnam, Cold War deterrence. These ships, built in months under wartime pressure by inexperienced workers, proved more durable than anyone predicted. They were supposed to be wartime emergency construction, quick and dirty ships that would serve their purpose and be scrapped. Instead, they became the backbone of American naval power for 3 decades. 3 of the Newport News-built Essex-Class carriers survive today as museums: USS Yorktown in Charleston, South Carolina, USS Intrepid in New York City, USS Hornet in Alameda, California. Visitors walk their decks, explore their hangar bays, stand on their bridges. They see the ships as static monuments, steel sculptures commemorating a past conflict. But the ships are more than monuments. They're proof of what's possible when a nation commits entirely to a goal. When engineers like Homer Ferguson refuse to accept conventional wisdom about what can and cannot be done. When workers like Sarah Morrison master new skills under impossible pressure. When an entire industrial system focuses on a single objective with absolute commitment. The Essex-Class construction program, and particularly Newport News Shipbuilding's achievement of delivering 1 carrier every 3 months, represented a perfect alignment of design, logistics, workforce, and will. Ferguson's modular construction system made rapid building possible. The STS steel specifications made the ships survivable. The workforce's dedication made both real, and the nation's commitment to victory made all of it necessary. Could it be repeated today? Could America build 10 fleet carriers in 5 years using the same methods? The answer is complicated. The industrial capacity exists. American shipyards, though fewer than in 1943, are more capable. Modern computer-aided design and manufacturing would make Ferguson's modular construction approach even more efficient. The engineering knowledge accumulated over 80 years would produce better ships, but the workforce is gone. Not the specific workers from the 1940s, they're nearly all dead now. The culture, the industrial culture that made rapid wartime production possible. In 1943, America had millions of workers with experience in heavy manufacturing. They worked in steel mills, automobile factories, machine shops, shipyards. They understood physical materials, mechanical systems, industrial processes. You could teach them shipbuilding because they already understood the foundational skills. Modern America doesn't have that workforce. Manufacturing moved overseas, industrial jobs disappeared, the knowledge base eroded. Young people today are far more likely to understand software than steel. They can code in Python but can't weld aluminum. These aren't value judgments. They're observations about how the economy changed. But those changes mean that recreating the Essex-Class construction miracle would require not just building ships, but rebuilding an entire industrial culture. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.